Oh, hi, everyone. I imagine you're here for the demonstration of IC.IDO that you were promised at this event and you came in today. And so we might as well get into that. But before I get started, pardon me, as I walk through here, one of the things that always comes up when people ask me to do demos recently is that they ask me to demonstrate IC.IDO Weave to them. And that's possibly something that's not so easy to do in a half hour or an hour because Weave really is not just a single software solution, but in fact a subscription model that allows you to flexibly go from working and authoring and doing your engineering workflows in IC.IDO Integrate or IC.IDO Build and Maintain, and then also allows you to host those multi-user, multi-person collaborative reviews that we call Colab. And that's probably what you're talking about here. So before we get into talking about Colab, maybe it's a better idea for us to first consider within IC.IDO Weave is, of course, IC.IDO Integrate, which is a level of capability in IC.IDO that we use to focus on, pardon my head, uh, focus on product integration workflows and the product detailing of packaging between the solid components and those flexible components like hoses and wires, making sure that the product has accessibility, installability, and appropriate clearances in between the individual components and, of course, their supporting hoses and wires, etc. We also want to make sure that there are clear installation paths and removal all the products, as well as dynamic and static space claim and clearances available for the parts so that operators can easily access, see, reach, and potentially install or service or assemble the products based on them. So let's take a look at some of these integration tasks that one might do when using IC.IDO Integrate package as part of their Weave subscription. With IC.IDO Weave, it is possible for individual engineers or even collaborative groups of engineers to launch IC.IDO Integrate interfaces on their local machines and either using desktop immersive capabilities, explore and experience the packaging of their product, both statically as far as space claim goes for the design position and dynamically for the installation and removal or service paths. Our real-time physics simulation engine will allow them to see the risk of collision or interference between other bodies in the assembly and the component they're working with themselves. Additionally, any of that access pass or installation or removal path can be saved, recorded, and exported out as CAD bodies that can be used to inform the rest of the engineering design. Additionally, it's possible to simulate with our physics engine the behavior of flexible bodies such as hoses, wires within the assembly. This will allow them to validate that all of the cables and wires and hoses have been engineered with an appropriate length. This is less common than you think because it turns out that many times when CAD engineers are drawing those bodies, they're instead drawing perfect cylinders or perfect pipes that don't properly represent the behavior of cables and hoses and wires in the assembly. Therefore, it's very necessary for us to validate the behavior of those cables. Do they have enough length to be plugged in? Sufficiently short length to prevent being pinched or trapped. When the situation arises that a cable is too short or perhaps too long, we can immediately, without pausing the IC.IDO review, edit that cable length. We can make it longer, we can make it shorter, and we can immediately validate with our real-time physics engine the behavior of that lengthened or shortened cable, ensuring that it's long enough to still be plugged in and unplugged when necessary for assembly and service, but also making sure that it's not so long that it risks becoming trapped or pinched inside of the assembly during use. Anything that we do with these cable lengths can be now saved, recorded, and exported back into the CAD system to further inform that engineering design and the engineering packaging. But because none of these decisions can be made in a vacuum just on the basis of one engineer's opinion or their conclusions based on the evidence, we can now see that it's possible for us to collaboratively validate that the changes to the engineering design, the lengthening or the shortening of those cables, the alteration of an engineering assembly order, or perhaps the repackaging or replacement of individual components within an engineering design can be validated in a collaborative engineering review. With our IC.IDO Weave package, whether you're opening an IC.IDO Integrate session or you're opening up an IC.IDO Build and Maintain session, it is still possible for us to leverage the latest in cutting edge XR technology so that we can again get very rapid, immediate feedback on the packaging and the integration of these systems and subsystems in our product design. And you can see here the use of the Vario XR3 to quickly validate that an engineer can easily see, access, and reach key components. So, one of the other things that we need to consider when it comes to using virtual and extended reality in order to validate our product designs is also to consider those processes or procedures that require human beings to participate in them. And for that, we might consider not just the product geometry, but also the procedures and the processes of how we assemble, disassemble, and service our products. So what we're going to look at next is a few demonstrations of how IC.IDO is able to take in a proposed process, or even inside of virtual reality, define a process, record that process by disassembling a part in virtuality or on your desktop, and then recording that and playing that back and deciding, is that an appropriate and valid assembly order? And giving people the flexibility to reassign or reorder that assembly, change the length of a procedure or a process step in that process, and then also take the findings from VR and export that back to the engineering system where it was originally designed so that we can benefit from that and capture that and cascade and keep that continuous in our digital thread. Let's take a look at that. Upon review of the assembly order, maybe we conclude that the assembly is suboptimal. In this last object to be installed is the furthest one in and have to reach past the other objects in order to install it. And maybe I would decide that it would be smarter and easier to make sure that the first thing that I install is the furthest in that I have to reach. And that way I'm not reaching over already installed components. And just by dragging and dropping and reshuffling that assembly order, we are in fact capturing and documenting a new assembly process that can be shared with our peers. We can experience it in virtuality, and we can also save and export that out as an engineering change request and feed that back into the system. In addition to validating the procedural order of assembly, it is also necessary to validate the tools, that is, these products that we buy that help us build our initial product. And so this tooling may be an overhead hanging gantry crane, an assist lift device, something that's going to help me assemble this vehicle. So in this case, we're loading in one of those large batteries into this electric VTOL, and we want to validate, is this tooling safe and appropriate for us to operate? Is it going to allow us to complete the job? Is it going to be effective? Is this a one-person job, a two-person job, or even more complex than that? And we're able to validate the tooling as well as the working environment where people will be completing this assembly task. Team that's responsible for taking any proposed procedure, tooling, or work environments and validating that it is safe and appropriate for our employees to be able to conduct that job. If we're doing an ergonomics or human factors assessment, what we're benefiting from here is one of our engineers has, in immersion, remapped her interactions with this VR scene to different sized and shaped people than she currently is. And this way, without having to ship a prototype all over the world or have people travel all over the world, we're able to see what it's like for different populations of workers to be able to complete these service or assembly tasks, or maybe even just operating a product. Validate that we have well designed our process, our work environment, and our procedures for the best performance. With all those individual inputs now collected inside of a common IC.IDO session, to launch this collaborative workspace, this collab environment using IC.IDO Collab. Again, that's that third expression of IC.IDO usage within the IC.IDO Weave package. I might have already done all of my packaging and accessibility studies using IC.IDO Integrate. I have already done my process definition, capture, evaluation, and improvement with IC.IDO Build and Maintain. And now it's appropriate for me to use that collab environment for me to have a collaborative review where I can invite multiple stakeholders from different organizations to participate in this shared virtuality where they can validate and approve the individual decisions that were made with those other parts of IC.IDO Weave. Thank you very much for your attention today.